In this section, we'll be looking at interference and our measuring tools. So let's click on our interference measure folder, and notice there's nothing inside of it because we're only filtering space claim documents. So click on the filter drop-down, and we're going to open up a step file. So go to Step Files and open up Pillow Block. So when importing models from different systems, it's oftentimes a good idea to understand what's going on in the part. So you might want to make a few measurements or check for interferences. So the first thing we're going to do is go into our Measure tab. The two buttons we'll look at first are Mass and Measure. If we click Mass, we can choose any of the solids and find the mass properties. Notice it gives me our volume, total surface area, and center of volume. But right now it's not displaying a mass. That's because there's no density or material associated with that solid. If we like to apply a material, we can go to our bottom left-hand corner of the screen. This is our properties panel. And one thing I normally like to set is a material property. So click on Unknown Material, and let's click on the drop-down. This will display a library of materials. So let's choose aluminum and click OK. Now it recalculates and uses the density in the properties panel to calculate a mass for our part. So our mass is 120 grams. If we click on another model, notice there's no mass here because there's no properties for it. So we'll go to Material Names, click on the drop-down, and we'll apply a material to this. Notice once I do that, a mass gets applied. Now one thing that's really useful is taking this data into another system. Once you make a measurement and this box pops up, those numbers are automatically copied to your clipboard, which means if I go into Microsoft Word or another text program, I can immediately click Paste and paste that information in. You may get too much information, but it's much easier to delete what's not needed and keep the few numbers that are there without having to type them all out again. Now let's look at measuring in SpaceClaim. I'm going to click the Measure tool and measure the distance and length of faces and lines and points. First, I'll click on a face. Notice it gives me the planar area of the face and the perimeter. If I Control select on another face and they're parallel, it gives me the distance between those objects, 4.763 millimeters, and there's no angle. If I Control select two faces and there is an angle between them, it will display the angle. It will also give you the length of edges or the distance between axes if you Control select two of them. But let's look at measuring point to point. I'm going to click on our point here and Control select on our point up here. Notice it gives us a straight distance between those 2 points. Now if I want to get the X, Y, Z distance, I can use our tool guide to let me select a plane or an origin. By clicking that tool guide, I can measure along an edge. So it gives us our straight distance and then shortest line. Or I can click that tool guide and click the origin to get the X, Y, and Z distances. Notice they're displayed on screen, and they're also displayed in that little box. And once we have the origin selected, if we single click any point, it will give us that X, Y, and Z distance from the origin. So we can see where any of the other points are located on our model. So take the time to make a few measurements and apply mass properties to two of the solids. Next, we'll look at interferences. You'll notice that there's an interference button inside of our Measure tab. And I'll click on Volumes. Now, one thing you'll notice is that if I click one solid and Control select on a second solid, it simply displays the amount of volume that's interfering. Notice it's almost 100 millimeters. If I Control add another solid to my selection, it'll tell us the new volume that's interfering. Between these three solids, there's a little over 1,000 cubic millimeters interfering with each other. But this doesn't help us remove any of the interferences, it just simply displays how much is interfering. If we'd like to go through and remove interferences, one way to do this is to use Prepare, Remove Interference. This interference button detects interferences on the entire assembly. It searches for anything that's visible. And here it's found 2 interfering regions. But to see how it's going to fix the interference, I'm going to first go into a cross-section by going back to Design, clicking Select, and selecting on an axis. I'll select on the axis running through our plug and click Cross-Section. That will put me into a cross-section through our assembly. So we can better see now what's interfering. Our orange area here, and our blue areas down here. If I go back to Prepare and click Interference, it displays those 2 interfering regions. Now if you click on either red area, it fixes the interference by always removing geometry from the larger of the 2 solids. In this case, the blue solid was larger than the orange one, so it removed material from the blue solid. In this case, the dark blue solid is larger than the light blue solid, so it removes material again from the dark blue solid. Now, sometimes that's not going to be the result you want. So I'll undo, and I use this to just simply show me where parts are interfering, because now I can go back to Design, use our Pull, Move, or Fill tools in this cross-section to remove the interference in a different way. I can pull the light blue face down, or even pull it up to our dark blue face. So take some time to look at our 2 interference tools and practice with showing the interference, calculating the volume, and also fixing it. Fix the orange plug using the automatic method, and fix the light blue interference using Pull.